Today we're going to look at intents. We're going to talk about Android's intent system in general. Then we will look at the anatomy of an intent. We will look at some common system intents, and then we will look at how we can request functionality be executed for us in Android with the help of intents and intent filters. First, what is an intent? Broadly speaking, an intent is simply a messaging object that we use to request an action in Android. Common actions are things like starting an activity. So whenever one activity, activity A, wants to start another activity, activity B, we call the start activity function and we pass an intent that specifies in some way which activity that is that activity B that we're trying to start. We can also use intents to start services, which is another top-level component, or to send a broadcast, which can be intercepted by a broadcast receiver, which is yet another top-level component. There are two types of intents. An explicit intent is one where the recipient is specified, whereas an implicit intent does not have a recipient specified. Instead, an implicit intent will have an action as well as other pieces of information, and Android will determine who should receive that intent. Here we see a basic illustration where an activity A intends to start an activity B that might be an explicit reference to activity B or just some activity B that Android inevitably matches. The intent is passed to a call to start activity. Android, upon receiving that request, will launch activity B if it is able and if activity A has permissions. Inside of each intent, we tend to find one or more of the following pieces of information: a component name, an action, a data element, one or more categories, extra information, and flags. A component is an optional entry in an intent. If the component is specified, that intent is an explicit intent. The intent is implicit if no component is specified. Examples of components that can be targets for an explicit intent are activities and services. An action is a string that specifies a specific operation that we would like performed. Based on the action, the rest of the contents found in the intent can be determined. Some predefined actions that you would find: the ability to share data, to set alarms, viewing content such as URLs, media, file locations, or contact information, as well as capturing media such as images and video. The data element in an intent is a pointer that uses a URI to identify some information that is meant to be viewed or acted upon by the recipient of an intent. In addition to the pointer to the data, the intent may also include a MIME type. This will help Android determine which component is best suited to handle that data. A category is a string that gives some more information on the component that should handle the intent. You do not need to explicitly specify a category for most intents. Additionally, whenever you create an implicit intent, Android will automatically add the default category for you to help in intent resolution. Examples of categories: browsable means the target activity can be started from a clicked link in a web browser or other location. Launcher means this component is going to be listed in the application launcher used by the device. Extra information are key value pairs that can be added to an intent. The types of extra values that are added to an intent are usually determined by the action or by some local protocol determined between two activities. Some examples of extra information are email and subject that might be used to provide email address and a subject for an email respectively. These would be paired with the send action, indicating to Android that we would like to send a particular piece of information as an email. Flags are additional metadata for an intent. They are used to instruct the operating system how we would like the recipient component to be treated. For example, we could set a flag of activity single top. Doing so would tell Android to override the default launch mode for a given activity that we are targeting and to instead launch that activity using single top launch mode. Activity no history tells the operating system that once we have completed using the recipient activity, it should not be listed in the list of previous applications or components used. An example of an explicit intent is simply one where we specify the recipient component by referencing its class. An implicit intent does not have a class specified. Instead, we'll specify a specific action and include any additional pieces of information that are required, such as extra information, data, or categories. Once we have created an implicit intent, it is good practice to verify that there is an activity that can handle the intent as specified. An attempt to start an activity using an implicit intent for which there is no valid recipient will throw an exception. If multiple recipients can receive an implicit intent, Android may show a chooser, allowing the user to pick which component or application they would like to receive the intent. The user may set a default recipient for future requests. The programmer can also programmatically display the chooser. An implicit intent is one part of the equation. An intent filter is a declaration to the operating system made by a component that it is able to receive and act upon an implicit intent. To declare an intent filter tag is placed as a child of the activity tag for the component that is interested in receiving a particular implicit intent. An activity can declare 0 or more intent filters. If no intent filters are specified, that activity can only respond to explicit intents. When a component attempts to start an activity using an implicit intent, Android performs an intent resolution process where it attempts to identify the best recipient for an implicit intent based on all declared intent filters currently on the system. When attempting to match an implicit intent to an intent filter, Android will perform 3 tests. The first test is an action test. In this test, Android will compare the action of the implicit intent to action tags placed inside the intent filter of a component. An intent's action must match one of the actions of an intent filter for that component to be considered a candidate for the next test. If a filter does not list any actions, then all intents fail, unless the intent itself does not specify an action. Once we have created a candidate list, we move on to the second test, which is a data test. When performing a data test, Android will compare the data element in an intent, if there are any, to the data elements of intent filters declared by components. When declaring a data element in an intent filter, we treat each aspect of the data as a separate attribute. The 4 possible attributes are scheme or protocol, host or server, port, and path. Additionally, a data element may have a MIME type specified. If the filter lists a MIME type, both MIME type and the data element in the implicit intent must specify the same MIME type. Once we have gotten through the second test, All components that have passed are moved to the third test. The third test is the category test. An intent filter can declare 0 or more category elements. A filter must match all the categories in an intent for it to pass. However, the reverse is not true. That is, an intent may have fewer categories than the intent filter, and in that scenario, it would still pass. When creating an implicit intent, Android automatically adds the default category. As such, an intent filter must declare the default category in order to receive implicit intents. Here we see an example of an intent filter. This intent filter is specified as a child of the activity tag for main activity. This means if an implicit intent matches this intent filter, our main activity would be launched by Android. Here we see that this intent filter specifies the view action. Additionally, it has a data element where the scheme or protocol HTTP is specified, and it has the host or server attribute www.mydomain.com. This essentially means that this intent filter is geared towards intercepting and launching our activity for any implicit intent that is attempting to visit the website www.mydomain.com. Because this is an implicit intent, it must specify the default category. Additionally, this intent filter specifies the browsable category. This ensures that this intent filter can intercept links that are clicked on a website. Here is an example of using implicit intents. Here we have an application that is built to perform some action. It really doesn't matter what that action is, but apparently if you click this button, all types of cool things will happen. In addition to the basic functionality of this application, we would like to give users access to a help screen. We're going to build that help screen on our company website to make sure that any changes that need to be made can be done simply without having to push out a new version of our app. In order for a user to get help, we would like them to click this link in the bottom right of our screen. Clicking this link will then open the website. Here we have a couple of choices. The first choice would be to embed a web view into an activity in our application and allow that web view to display our help website. The problem with this approach is that for the user to have a full experience, we would have to build in a lot of extra features. For example, what if the user starts to follow links on that help site? We would need to give them a way to be able to go back. Or what if the user wants to bookmark a specific URL so they can visit it again later? We would now need to build that functionality into our application. Before we realize it, it would be as if we're building a full-fledged web browser into an application that has nothing to do with browsing the web. Because of this, What we would prefer to do is to use the second approach, which is have Android launch a web browser that is already on the device, allowing the user to view our help site and having available to them all the features of a standard web browser, including being able to browse and bookmark. In order to do that, we're simply going to ask Android to launch a web browser whenever the user clicks the Get Help link. To do that, we will simply attach an on-click listener to our link. The ID for my text view is r.id.getHelpLink. For the listener, I will simply start activity. But which activity am I starting? I want to start an activity based on an implicit intent meant to view. I want to view a URL, so I am going to use the intent.actionView reference. Intent.actionView is used for all view actions in Android. Now I need to specify what I would like to view. I will do that by providing a data element. Data accepts a URI, which is Uniform Resource Identifier, which is going to be a globally unique pointer to the data you would like to view. In this case, the data is a URL, which is Uniform Resource Locator. A URL is a subset of URIs. As such, I can provide a URL as data for my intent. In order to provide the URL as a data element, I will use the parse function of the URI class, where I will provide my URL as a string. Let's assume that our help site is wikipedia.com. This is enough information for Android to determine a component that is able to view this type of information. If I run my application, I can now click on the Get Help link, and my application will launch the web browser. Hitting back on the web browser brings me back to my application.